So welcome to the analysis tools section. This one is of the most, let's say, extensive ones because we are going to understand what type of tools we have in order to report physical properties, thermodynamics, transport, etc. So this section is divided into 6 subsections. It has pure property, PT envelope, binary systems, mixtures, ternary systems, and residual curves. Okay, so every time you click on a button in the analysis, let's say ribbon, you will open a form in the analysis folder. Okay, just keep that in mind. So let's start with pure component. Actually, what's a pure component? You know, guys, that a pure component is any substance that has a definite chemical structure. And well, you can do this for water, ethanol, maybe if you are modeling gasoline as octane, you can do it as well. If you're modeling natural gas as methane, you can do it as well. So this is very useful if you are using one single component, which is not always the case, but it really helps us for understanding properties. So if you're using a plant generation system, you will want to know the properties of water at different pressure and temperature. You can do that as well. You might want to get some thermodynamic properties, Gibbs free energy, entropy, enthalpy, etc. For vapor, liquid, or maybe even solid, you can model that as well. Then we continue with the binary. Now PT envelopes, you already know what an envelope is. This little diagram in which you see two curves, the dew point and the bubble point. Typically we assign this as pressure, temperature, and this is very useful to understand when do we have a vapor liquid mix, when do we have only vapor, when we have saturated vapor, or when we have a liquid or a saturated liquid. This works as well for pure and binary substances, so that's tricky because when you have binary mixtures, you know there might be a vapor liquid mix, and when you have a pure substance, you might as well have it. Okay, so just keep that in mind. Let's continue. We're going to see how to merge plots in Aspen plots, very important. Continue with binary mixtures. This is one of the most important sections because with the binary interactions, we know if a substance or a set of substances works with ideal, or if we should treat this as real solution, or maybe even it has two phases. So that's very important. We're going to see mostly TXY and PXY diagrams, which is composition versus temperature and pressure. Even though we still have Gibbs free energy of mixture, you can show it as well. We're going to see maybe 1 or 2 workshops. And phases that we're going to use, mostly vapor liquid and vapor liquid liquid. Those are mostly. Then we continue with the mixture analysis. As the name implies, this is used for any kind of mixture. You can even use 1 component, 2 components, 3 components, whatever number of components you can use them. And what we do is analysis of the property sets that we have seen on the last sections. We are going to select those, and you're going to run from pressure and temperature ranges. You just click run, and Aspen Plus will generate a report of the given mixture and the given properties. Then we see ternary mixtures or ternary analysis, in which we see the ternary diagram. You know, this is the typical triangle which shows each side of water, maybe ethanol and octanol and so on. This is used mainly for liquid-liquid equilibrium, or maybe if you are using also vapor liquid-liquid equilibrium as well. We will see the curves, how to identify azeotrops, how to search for them, and not only that, we are going to identify the famous ternary azeotrops, in which the 3 substances have an azeotrope. Then we check out the residual curves, or residue curves. It's nothing more than the interaction of what will happen if we boil this in this pathway, or this pathway. You will see that a little bit on theory on that, and we finish with the analysis tools. So hopefully you enjoyed this section. I really did when I was learning that when I was younger. It's really cool, especially the binary diagrams. It's much easier to model, and I hated it because if I will have this tool when I was studying thermodynamics, I will understand the difference, the interaction between substances, but that's a shame that I already knew, I passed the subject, and now I have this tool, so I say, well, it will be better if we had this before. Anyways, guys, see you in the next lectures.